Hi guys, so I'm making another statics example problem. This one will be from chapter 7. It's about moments and shear forces at certain points, so hopefully this can help you with some of your homework questions. Okay, so here's the problem. What we're going to be doing is determining the internal normal force and shear force and the bending moment in the beam at both points C and D. The problem is telling us that support B is a roller and point C is located just to the right of the 8-point kip load. So at that point B, which is a roller, we have that 50 kips times feet value. And then there's a force of 8 kips acting at point C. So we're going to take that diagram that the problem gives us and we'll convert it into our free body diagram. So you just kind of go over where all the forces are acting. So let's start with point A. There's that pin on the ground, so that means that there'll be a force in the y direction and x direction. And then at point C, we have that 8 kips acting down, which will show. And then at point B, we have that moment and a force acting in the y direction. So in order to find the values that the problem is looking for, we first need to calculate the values acting at point A in the x and y direction and the values acting at point B in the y direction, because these values will be important later in the problem. So to do that, we first take the summation of moments about point A, and we know that in this case we're going to use counterclockwise as positive throughout the problem, and then we know that this moment total is going to equal 0. So we're going to set equal to 0 all the forces that would cause a moment about A, which are By, and then its distance from point A, which is 24, and then plus that 50 kips times feet. And then we're also looking at that force acting at point C, so 80 kips, and then it's 8 feet away. And then after some algebra, we find that By will equal 1.714 kips. Then we're going to apply the equation of equilibrium in the x direction so that we can solve for Ax, but like we said, these are going to equal 0, and Ax is the only force acting in the x direction in the system, so we can say that Ax equals 0. Then we do the same thing for the y, except there's going to be a few more forces at play. So once you add together all of the forces acting in the y direction, we can see that AY equals 6.286 kips. So now we're going to focus only on point C, and in order to do that, we will create a free body diagram showing what's going on at point C. So we have that AX and AY that are having an impact on point C. Obviously, we have that 8 kips that's acting right on point C, and then there's always going to be that moment about C, as well as the normal C and the VC. And now that we have that free body diagram showing what's going on at point C, we can calculate the NC, VC, and MC, so kind of those unknowns. So in order to do that, we'll kind of do the same thing that we did with the A forces. So we'll apply that equation of equilibrium in the x direction. So that shows that the NC is actually 0 because all the forces have to equal 0. And AX is 0. So basically here we're just kind of applying some algebra to figure out the forces. We do the same thing in the y direction to figure out VC, and then we'll do the summation of moments about C and set that equal to 0 in order to find MC. And now we're going to do the same thing that we did at point C, but for point D. So we'll make that free body diagram again, showing the moment about D, the normal force at D, the VD, and then also acting on point D is that moment about the entire rod. And then lastly, we're going to calculate the ND, VD, and MD. So those unknown values, we're just going to do the same thing that we did before with those equations of equilibrium, where you total up all of the forces acting in the x direction and all of the forces acting in the y direction. Both equations have to equal 0, and then you do some algebra to figure out your ND and your VD, And then to find the MD, we're going to do the summation of moments about D, set that equal to 0, and we find MD to be 60.712 kits times feet. So that's the end of this problem. All the boxes show the answers to the questions. But if you have any more questions just about the process or follow-up questions about problems similar to this, please let me know. Schedule a session or via email is fine. Hope this was helpful, and I hope that this can help you when you guys are learning more about Chapter 7.